Using the limit definition of the derivative, find the derivative of f of x equal to 1 over x. All right, so the first thing you should know the limit definition of the derivative. That basically says f prime of x equal to limit as h approaches 0, f of x plus h minus f of x divided by h. Okay, so as you can see, we need the value of f of x and we need the value of f of x plus h, right? We already have the value of f of x, which is already given to us. However, we don't know the value of f of x plus h, right? But we can find that out. So what is f of x plus h, right? So the best way to find out the value of f of x plus h is using placeholder. Okay, so that's what I'm going to do. I'm going to replace all the x with a placeholder like this. Okay, so that basically means we are substituting all the x with x plus h. So x plus h, x plus h. All right, since we cannot simplify this anymore, we are going to leave it as it is. Okay, we are going to leave it as it is. Okay, so now we know the value of f of x and f of x plus h. What we can do now, we can just plug it in and we'll be done. All right, let's do this. So f prime of x equal to limit as h approaches 0, f of x plus h minus f of x over h, limit as h approaches 0. All right, so what's the value of f of x plus h? We already found that, which is 1 over x plus h minus f of x is already given, 1 over x over h. Okay, now at this point we want to simplify this problem as much as we can, right? The reason is we can't just plug it in. We can't just replace h with 0, then we are going to get undefined, and we don't want to get undefined. We want to simplify this problem as much as we can so that we can find out the derivative. Okay, so now we are subtracting two fractions. So let's take a look at our numerator. Okay, so we're subtracting two fraction. When you subtract two fraction, what needs to happen? Their denominator must be the same, right? So x plus h and x, how can we make them the same? This is what we can do, x plus h. So what I'm going to do, I'm going to multiply top and bottom by x minus, now I'm going to multiply top and bottom by x plus h. And I hope you understand why I'm doing this. I'm doing this to make sure that I have the same denominator. Okay, so once your denominators are the same, you can add or subtract the numerator, right? All right, so let's solve this. So limit h goes to 0. I'm going to leave h as it is. Let's do the top part. I also have, all right, so now my denominator is the same, so x plus h. So I have x minus, now there's a common mistakes that many people make. The mistake is they do not use parentheses. Okay, so you must use parentheses, because this negative sign is going to change the sign. Okay, so you must use this parentheses. Do not forget to use parentheses. Okay, this is a really common mistake. Do not make this mistake. All right, so limit as h approaches 0, I have h in the bottom. On top, in my denominator, we have x plus h, x minus h, right? So x and x cancel each other out. Wonderful. Let's simplify. All right, let's do this problem step by step so that you can easily understand what's going on. So limit h goes to 0. So I have a fraction. The bottom I have h, but on top I have negative h over x times x plus h, right? Okay, wonderful. All right, so when I see this problem, it kind of reminds me of dividing fraction. So it seems like I'm dividing to fraction, okay? So think of it this way. Think of h as h over 1, okay? Now, I hope all of you remember how to divide fraction. How do you divide fraction? Keep, change, flip, okay? Don't forget, keep, change, and flip. And that's exactly what we're going to do. So limit as h goes to 0. So we're going to keep the top part, okay, which is a negative h over x plus h. Division will change it to multiplication sign, and we're going to flip the bottom, okay, the denominator. So 1 will go on top, h will be in the bottom. Okay, we're almost there. Now we can cancel out h and h. So we have limit as h approaches 0. I have negative 1 on top because I have this negative sign here. X plus h. Now the question is, can we plug it in? The answer is yes. We can replace the h with 0. So negative 1 over x plus 0. All right, so once you replace h with 0, you don't have to write limit, okay? You don't have to write limit. All right, so let's simplify this. So that's going to be negative 1 over. So x plus 0 is just x times x is x squared. So this should be the derivative of the function, okay? Now, I will be really happy if you always double check your work. So let's double check the work. So d over dx, 1 over x, right? All right, how can we write this? We can write this as d over dx, x raised to the power negative 1. Again, x raised to the power negative 1 is equal to 1 over x, okay? So they are the same thing. We can write x raised to the power negative 1. Now we can apply the power rule for derivative. Negative 1 comes in the front, x stays the same, and negative 1, right? So that's going to give us negative 1, x raised to the power negative 2. All right, so negative 1 will remain the same. X raised to the power negative 2 can be written as 1 over x squared. And we found the same answer. So our answer is correct. If you like this video, don't forget to subscribe.